Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, New St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, Crossing New Frontiers to Conquer Today's Challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, New St. Augustine.
Thank you. I'm Philip Emeagwali. Who invented the internet? The internet has many fathers and mothers, as well as aunts and uncles. But only one father of the internet invented a new internet. The father of the internet should at least contribute new technological knowledge that pertains to the internet, and do so by inventing a new internet. I am called a father of the internet because I am the only father of the internet that invented a new internet. I invented my new internet by first theorizing it on my drawing board. I drew my new internet as a new global network of 64 binary thousand processors that I also visualized as a virtual supercomputer. After 15 years of conducting research at the farthest frontiers of knowledge in algebra and calculus, I developed the intuitive feeling that I could figure out how to solve the grand challenge problems of supercomputing and solve them by parallel processing them across a new internet. After those 15 years, I developed my intuition on how to record the previously unrecorded speeds in supercomputing that I recorded back on July 4, 1989 in Los Alamos, New Mexico, United States. That supercomputing achievement was why I was in the news headlines for discovering how to compute fastest and do so across a new internet. The record supercomputer speeds that I visualized were how to execute a humongous set of floating point arithmetical operations and how to execute them 65,536 times faster, and how to execute them across my new internet that is a new global network of 65,536 or 2 raised to power 16 commodity off-the-shelf processors. Each of those 64 binary thousand commodity processors were identical to each other and were equal distances apart from its 16 nearest neighboring processors. I visualized my 2 raised to power 16 processors as etched across the 15-dimensional mathematical hypersurface of a hyperglobe that I also visualized in the 16th dimensional hyperspace. I allowed my intuition to guide me, in part because I visualized how I could record speeds in email communications and do so to and from each of those 65,536 processors. I visualized how to execute and record email speeds that will be 16 times 2 raised to power 16 or 1 binary million times faster, and how to do so across my new internet that was outlined by my new global network of 48,576 email wires that I visualized as mutually perpendicular at 2 raised to power 16 points on the surface of my hyperglobe. After 15 years of supercomputing, that was onward of June 20, 1974 in Corvallis, Oregon, United States, I developed an ability to understand how to massively parallel process across millions upon millions of processors. That decade and a half supercomputing experience gave me the confidence to attempt solving grand challenge problems that other supercomputer scientists shied away from. I solved the grand challenge problem of computational mathematics because I was able to metaphorically visualize it around a globe in three-dimensional space. I visualized that globe as representing planet Earth that was enshrouded with fluids, namely the oceans and atmosphere. And I was able to visualize a second hyperglobe in the 16th dimensional hyperspace. That hyperglobe was also encircled with 2 raised to power 16 processors. Comparing both globes and their associated global networks of tightly coupled processors was akin to comparing a circle that circumscribed a square to a sphere that circumscribed a cube. As an aside, the inspiration for my new supercomputer first entered into print as a science fiction story that was dated February 1, 1922. In that science fiction story, 64,000 computers solved the initial boundary value problem of mathematical physics that governs the flow patterns of the weather around planet Earth.
Insightful and brilliant lecture.